Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now let me show you a couple of examples of how to balance chemical equations. So example 1, burning of a natural gas that contains methane. So methane is CH4, it's a hydrocarbon, plus oxygen, so this is a combustion equation, goes to carbon dioxide, CO2, plus water. So when you first look at this, you might think, oh, like this is an equation for the combustion of methane, but you can't immediately jump to that conclusion. You have to make sure that each of the elements or compounds are balanced. And now let's take a look at it really quickly. We have 4 hydrogens here, but we have 2 hydrogens here. We have 2 oxygens here, but we have 3 oxygens here. So there's clearly something that needs to be done. So the key is to balance the element that occurs the least. So in this case, the carbon and the hydrogen. So first off, let's look at the carbon. We have 1 here and we have 1 here. Great, we don't have to do anything. Now let's look at the hydrogen. We have 4 here and 2 here. So we're going to have to put a 2 right here to balance the hydrogens. So now the oxygen occurs in 3 species, so we want to balance this last. But now we got to 2 oxygens here, 2 oxygens here, and 2 oxygens here after we balance the hydrogen. And so it's very straightforward, you just put a 2 right here to balance out the oxygen. And now you have a balanced chemical equation for the combustion of methane. So a second example is the combustion of butane. So butane is another hydrocarbon and has the formula C4H10. So now again, let's react it with oxygen, which is combustion. You get CO2 and water. And again, we want to balance the element that occurs the least, which is carbon. So we have carbon here, we have 4 here, and we have 1 here. So clearly we need 4 carbons right here. Now let's balance the hydrogens. So we have 10 hydrogens here, 2 hydrogens here. We clearly need to put 5 here to make it 10 hydrogens on both sides. Finally, let's balance the oxygens. So we have 2 here, 8 here, and 5 here. So don't panic, although it looks like a weird number. You can actually write the amounts of each thing as fractions. So for oxygen here, we can actually do 13 over 2 in order to balance out the reaction. So now multiplying both sides of the equation by any number does not alter the balance of each atom type. So I can multiply everything by 4, everything by 5, it doesn't matter because the ratios will still be the same. So in this case, in order to make everything a whole number without any fractions, I'm going to multiply everything by 2. And your final balanced equation will be 2C4H10 plus 13 oxygen goes to 8 carbon dioxide plus 10 H2O. So balancing equation is pretty straightforward. You always just have to start with the element that occurs the least and then just keep going forward. And when you get your final answer, make sure that it makes sense and it actually does balance out. And that's a really easy thing to check. You have 8 carbons here, 8 carbons here, 20 hydrogens here, 20 hydrogens here, 13 times 2 oxygen molecules, so 26 over here, and we have 16 plus 10, 26. Correct.